to pray for each and every one of you, that this year will be a better year for you and your loved ones in Jesus' name. So,
Amen.
we are continuing by God's grace.
Amen.
So we're looking at module 5, which is sequential circuits. Within the next 1 hour, 1 hour plus, I will try and cover module 5 and module 6. And then after the class, I intend to give you a class work to be done and be submitted before the end of this period. So I will advise that you pay close attention to everything that we'll be doing in your own best interest. Okay? Now, let's look at what we have before us. We're looking at sequential circuits, part 1 and part 2. Sequential circuit, part 1 and part 2. Under this part 1, which is module 5, and then we'll be looking at basic flip-flops and timing diagrams. Module 6, we'll be looking at part 2, where we'll be looking at some other topic under sequential circuits. Now, very quickly, let's look at what the overview of what we'll be talking about, maybe for the next 30 minutes or thereabouts under this particular topic. We'll look at exactly what are sequential circuits. What are sequential circuits? We'll look at what they are. And then we will look at memory elements. We'll also try to look at basic type of flip-flops. And then we'll look at timing diagram and the analysis. And finally, we will also look at the various applications and design consideration under this topic. Okay? Now, what are sequential circuits? What are sequential circuits? Now, normally, if you have normal circuit that are not sequential, usually input is what determines the output for general circuit that you know about. For instance, if you have a circuit, like, let me give you an instance. Let's say electric circuit in your hostel. The input is actually what determines the output. What do I mean by that? For instance, if the voltage that is being supplied by BEDC to your house is a sinusoidal in nature, definitely what you will get in the house to power any device within your apartment will definitely be a sinusoidal signal. Okay? It cannot be square wave, or it cannot be a DC signal. It will still be an AC signal. Now, if it's coming to you and the voltage you have there is, say, for instance, you have 200 volts, which might not be necessarily be up to the expected 220 volts that you are expecting. Then what you may see again is that in that kind of situation, you may have a stabilizer that you want to say you want to boost it and ensure the light is up to whatever you need to power any device in your apartment. But one key thing there is that your input is still what determines what we get at the output. Okay? Your input is still what determines what we get at the what? At the output. So you won't probably get anything that is outside whatever the input is. However, in the case of sequential circuits, the circuit output does not just depend on the input only. It also depends on the history of that circuit, the previous state that that circuit is. Okay? And I will give you a typical instance so that your mind can be open to broader applications. I believe you are listening to me. Now, if you look at your laptop, for instance, your laptop, if you shut it down, definitely what happens is next time you are opening it, whatever document you didn't save in your system, whatever document you have not saved before you shut down, those documents are lost. You won't be able to recover them except through some of the procedure for recovery. Okay? But Let's assume you open maybe about 5 Word documents down on your system, and you choose to hibernate your system. When you resume from hibernation, what happened? You will still have access to those documents where you stopped. Nothing has changed, even though the power is disconnected. So what is happening? Definitely, what happened is you have certain sequential circuits within the computer system that is able to remember the past states while you are shutting down the system, and is able to bring that document back for you to be able to update what you have. Okay? And so when you talk about sequential circuit, what should come to your mind basically is this, that what? That your output is not just dependent on the inputs, but also it depends on what? On your past history rather. The output of a sequential circuit, it depends on what? Not just what? Not just the inputs, but also it depends largely on the past history, or what you can simply refer to as what? Uh, the previous states of that particular circuit, okay? And the basic component we can be talking about in sequential circuits includes the memory elements. For memory elements, you'll be talking about flip-flops, okay? We have different type of them. Then we also have what we call the combinational logic, and then we have the clock signal. Let me take them one after the other. When we talk about the memory element, we are simply referring to a sequential logic that uses memory elements such as flip-flop or latches to store the state of the system. Okay? Sequential logic that does what? It uses memory elements such as flip-flop to store information or store the state of the system. Okay? And the state changes is based on the input signal and the timing the signal comes in. Those of you trying to write on the screen, I don't think you need it. If you must write anywhere, write in your notes and take note of whatever I'm saying. That will be the best. Okay? That will be the best we can do now. Not just for you to be playing with the system. Okay? Listen and take notes. I've said I'm going to give you a classwork to be done before this period is over. Who is Maro? If you continue this way, I will remove you from this class. Okay? So nobody should write on the screen again. You don't have anything to do with the system now. Write with your notes. Is that okay? Now, then let's look at the combinational logic. These ones are state-based operations. And the output of this combination of the output of this particular one depends on the combination of the inputs and the state of the system. Okay? Please take note of the difference. The output of this particular sequential circuit is what? Is determined by the combination of the current input and what? And the current state of the system. Okay? And the last aspect, or the last one, is the one that we refer to as the clock signal. This particular sequential circuit, this particular sequential circuit is actually synchronized with the clock signal. Okay? As the name is, it works basically with the clock signal to achieve whatever it needs to achieve as far as sequential operations are concerned within the logic system. Now let's look at the basic concepts or the basic memory element, like I explained briefly earlier. Now, for the memory element, the first one I mentioned, this one stores binary information. Next is that it maintains the state until it's changed. And then the basic building block is what? What is the basic building block? The basic building block there is a latch. Okay? The basic building block there is what? The basic building block there is what? I need your response once. You can just simply unmute yourself. And then, so let me be sure I'm speaking to some students, not just talking to myself. Okay? So, now, okay, that's all right. Then, what is a latch? Does anybody want to make attempts? What is a latch? What is a latch? What comes to your mind when you hear latch? Huh? As the figure shows you, a latch is just one of the basic building blocks that you have in sequential logic, okay? It's like a multi-vibrator, bistable in nature, and it has just two stable states. It can either be 0 or 1. And what it is used for is just to store the binary information, okay? It's used to store binary information, okay? Now, unlike the case of flip-flop, latches are level sensitive, okay? Rather than edge sensitive. What did I say? Latches are what? They are level sensitives, unlike what? Flip-flop that are what? Edge sensitive, okay? So the implication is that their outputs changes whenever the control signal changes, okay? Let's look at the clock signal. For clock signal, you can look at what we have here. You have the formula, the period. I think some of these one you must have come across them in physics. Now, period T, okay? Talking about time taken to complete one evolution, okay? So meaning if you start from here and then you go up here, you come down here, meaning you have completed one cycle at this point. Can you see my zooming pointer? So, okay, good. So it's one cycle complete here, okay? And so if you are looking at the period, okay, the period for this, then we'll simply use this formula to determine the frequency. Period is time taken to complete one oscillation, okay? The period is time taken to complete one oscillation, okay? For instance, if I want to graduate this, and I say this is 5 seconds, and I say this is 10 seconds, and I say this is 15 seconds, this is 20 seconds, okay? The time taken, as you can see, from here to here will be what? Will be 10 seconds, okay? With 10 seconds. So if I need to calculate the frequency of this clock signal, okay, it will be F is equal to 1 over 10. And that will give me what? 0 0.1. 0 0.1 what? What will be the unit? The unit will be what? The unit will be Hertz, okay? The unit will be Hertz. Please take note of that. Hertz, Hz, that's the unit of frequency, okay? Now let's look at a typical flip-flop. A typical flip-flop. The flip-flop we have here is the one that is called SR flip-flop. SR flip-flop. Set, reset, flip-flop. So S stands for set, R stands for reset. Set, reset, flip-flop. Okay? Now, looking at the circuit diagram of the flip-flop is what you have up here. It has two inputs, set and reset as the input, and it has two outputs, which is Q and Q prime as the output. And you have the flip-flop circuit within this box. Okay? Now, we have the truth table as usual. You have 0011 and then a 0101. We have done all this. You are familiar with it. Talking about setting up this input, S and R. when you have set and resets, okay? Remember, we are discussing a sequential circuits, okay? And we said the output of sequential circuit is not just a function of the input, but rather the function of the previous states, okay? It's also considered. That is also a factor. That is also a factor, okay? Now, looking at what we have here, in the case of SR flip-flop, okay? What we have here is this. We have a situation whereby if set is 0 and your reset is 0, what you have there is nothing but what? The Q will give you what? The output will give you what? It will give you that what? There is no change. Usually we call it an invalid output, okay? It's an invalid output. When you have 0, 0, it's an invalid output. That is, the state is not valid, so nothing will show. Then let me also go to the last one too. Remember, I said we have two outputs. Please take note of this. On this table, I'm only showing the Q, okay? I'm only showing the Q here, okay? So when I'm here for this Q, here with me, this is Q prime. When I'm here for this Q, what happened is what? There is no change in this place. There is no change in this place, okay? There is no change in this place. And then when you have 0, 1, when you have 0, 1, then what do you have here? You have 0 as your output. Then when you have 1, 0, you have what? 1 as your output. Then the next one is when you have 1, 1, for the case of Q, what do you have? You have invalid. Okay? This no change simply means what we experience here is that the previous state is what will be reported for you. I don't know if I'm communicating.
Yes, sir.
The previous state is what will be reported for you. Okay? So here will be invalid. Now, when we have Q prime, which is not shown here, Q prime now, what do you think will be this one now? It's a flip-flop. Okay? It's a flip-flop. What will happen at this stage now?
Invalid.
This one will be invalid. Great. And this one will become what? 1. This one will become 0. And this one will become what? No change because it will still maintain the previous states. I don't know if that makes sense to everybody.
Yes, sir.
Is that understood by everybody?
Yes, sir.
Yes, sir.
Is that understood by everybody?
Yes, sir.
Okay. Or let me ask the question this way. Is there anybody who doesn't understand what I've just explained?
No, sir.
We understand, sir.
Yes, sir. Yes, sir. No, but I don't understand, sir.
Who is the I don't understand? Which parts you don't understand?
The set reset flip-flop itself, sir, using the truth table.
Okay. Let's go over for the sake of those of you that don't understand. Now, if you look at this circle we have here, we have two inputs, which is set or resets. Okay? Then we have the output. The first output is Q, and the second output is what? Q prime. Is that okay? Now, the SR flip-flop is actually constructed using NAND gates. What did I say?
NAND gate.
So it is constructed using NAND gate.
It's constructed using what? NAND gates. It's just that it has a little bit different logic behavior. Is that okay? It has a little bit of logic behavior. Okay? but that's the circuit that is used. The basic difference that you have between the SR flip-flop and the NAND gate that you are familiar with is just that in this case, you have one of the outputs built with a NAND gate and the other one built with NOR gates lying in between the logic triggers. Okay? Unlike the normal NAND gate, whereby you will just simply have that you normally just have what do you call it now? You will just basically have one output. Is that okay? Remember, in this case, we have two outputs. So the behavior and the performance lies just in between what you have in NAND gates and in NOR gates. Is that okay? If you read more about that, you may get more information as to how it is done. Okay? Now, very quickly, let's look at this for the benefit of those who didn't understand. This is a truth table, and we have two input circuits, obviously. These two input circuits we have. And then, as usual, you can populate this 0, 0, 1, 1, 0, 1, 0, 1. Is that okay? That you can do. I believe that. Now, in this table you have on the screen here, I only have one output that is being shown. I expect by now, those of you who are following me, you should have been able to do the two table in your own notes and put the Q prime output for those of you who are following. Okay? Now, the Q output here, when you have 0, 0, okay? This one we simply say there's no change. That is, this circuit will maintain the previous states that the system in. Okay? Then when you have 0, 1, this will become 0. And when you have 1 for your set and your reset is 0, what you will have here is what? Is 1. Okay? Then if you come here, you have 1, 1. What you have here, what? Is an invalid situation. Okay? Now, let's look at what we have here. If you have 0, 0, sorry, if you have 0, 1, in the AND, what will it give you?
1.
It's supposed to give you what?
1.
1 and 1.
In AND,
Give you 1. In that's all.
0, 1 give you 0. 1 and 1 give you 1.
0, 1 will give you 0. And then the 1
Yes,
and
1 and 1.
look at it now. These two
1 and
ordinarily supposed to give you what? Look at it. 1, 0, 0, 1 supposed to give you what? Like this one supposed to give you 0. Isn't
0,
it?
0, 0. 0.
Both of them supposed to be 0. Is that okay?
Yes.
Both of them, sir.
Then
Yes,
when
sir.
you now apply NAND, we said it's a special NAND. Okay? A special
Yes, sir.
NAND. Okay? So
Expect-
applying NAND to this output, meaning you will
Both of
have
them,
1
both of them will give
instead
us
of having 0
1.
for the two places. Does it make sense?
Yeah, both of them will have 1, 1.
Okay. But you know, we are looking at a special case of NAND.
Of NAND.
Are we
sir.
together? And look
Yes,
at
Yes,
the
sir.
when you have 1, 1, you have what? An invalid
0.
situation.
Valid situation.
Is that okay? So you need to be familiar with this, how this is done. Okay? Then look at the next situation you have here. It's just like you are saying Q prime. What you are having here is just like you are inverting the whole process. It's Q prime. So where you have 0 here becomes what? 1. Where you have 1 become what? 0. And where you have invalid will be replaced with this, whereby you will now have what? You will have a no change or previous state. And then this one where you have no change will become an invalid what? State. I think that should be okay for now. You can read more from the textbook I've shared with you or from any other textbook to get better understanding. Let's look at the next one. We have the D flip-flop. Okay? D flip-flop. By D, we're talking about either you call it data or delay flip-flop. Data or delay flip-flop. Okay? As usual, it also has two inputs. Okay? You have the data or the delay signal going in. Then you have the clock signal also going in. There. Okay? Now, looking at what you have here, you have a single input. This clock is just the clock coming from the circuit. So you have a single input going in, and the output follows the input, the clock edge. Usually, it has its application in a flip-flop, and then it doesn't have any invalid states. Okay? So what you will usually have, here you have 0, 0. So we have the complement of it as output. Okay? Because, you know, we're talking of flip-flop. Are you following me? And it has an input. Are you following me? It has an input, just one input. So that input can either be 0 or 1. Are we together? Two inputs, you have two inputs, and you have one input. You have one input, which is the D. And this D can only assume the state of 0 or state of 1. It can only assume the state of 0 or state of 1. Are you following? And so if it can only assess those, either of the two. So what we have next is that when 0 goes in, it means at the output, you will have the complement of it, 1. And if 1 goes in at the output, what we have is what? 0. Okay? Let's look at JK flip-flop. JK flip-flop. So in the case of JK flip-flop, it is an improvement over what you have as SR flip-flop anyway. Okay? And then it has it's a universal flip-flop, of course. It's more common. And then it's useful for toggle operation. What we mean by toggle? Toggle operation is if you can, when we say toggle, just like interswitching, okay? Toggle button. If it's 0, it can change it to 1. If it's 1, it can change it to 0, okay? And then you have the circuit diagram looking like this. Remember, clock is not part of the input. So you have J and K. You have J and K. And then J simply represents, is similar to what you have as a set in a SR, and K represents what you have like a reset in a SR flip-flop. So what does your J does? Your J usually maintain a high position. That is talking about maintaining a 0 position most of the time, okay? And it causes the output to be set at high as well when the clock signal triggers. Remember, this one will be a function of the clock now, okay? And then whenever K is also high, this one will also cause the reset to go to 0, okay? When K is high, it causes the reset to go to 0. Let's look at the truth table, for instance. So you have the Q as the output, a Q output here. Your Q output, if you have 0, 0, what do we look at it? Q output T plus 1, talking about the time T plus the next state. Okay? The time T plus the next state. That's what we're talking about. Okay? Now, if you look at what we have here, if you have 0 and 1, the output you have here is similar to what you have in SR. And here also, you will have what is known as a what? A 1. So unlike the other one that you have an invalid state. In this case, we don't really have an invalid state. Okay. So what we have here is that we have the existing states. This place and here, you will have an inverted state of that particular JK flip-flop. So we can say that based on what has happened, or based on the improvement we have on SR, been able to overcome the invalid state that you have as an inherent part of the SR flip-flop. JK has been able to overcome that because there is no invalid state there. Rather than for you to have an invalid state, what does it do? It will now take you to the next available states. Okay? It will take you to the next available states. I don't know if I'm communicating, or can I pause here to also get you?
We are not understanding, no.
We. There's nobody like we, oh. So if you want to speak for yourself, who is that person speaking?
Okay. James.
James, okay. James, you don't understand. Which part are you finding difficult to understand? First of all, look at the circuit diagram we have. Look at the circuit diagram we have. But you understood the SR, right?
Yes, sir, I understood. I'm just saying that it is a modified version of SRO flip-flop.
Exactly. If you look at the circuit we have on the screen here, in place of, look at this place now, this side I'm hovering over, you have an additional signal coming here from the clock. Okay? Yes. So the signal coming from the clock is helping this circuit to be able to capture what is coming from the clock of the circuit, of the sequential circuit. Are you following?
Yes, sir. Yes, sir.
And your J and your K, your J and K here is representing what you have in the other one, like your S and R. Okay? And you have the Q and Q prime outputs. Okay? Now,
yes, sir.
Here, I said I have Q into T plus 1 here. You follow me? Now,
yes, sir.
I'm saying my Q into T plus 1 is the next state. Q of T is my present state.
Present state.
Are you getting me now? Talking about the previous state I'm working with. Are you getting me now? Let me quickly over back to this place. This is my SR. Is that okay? When I say no change, I'm talking of my Q of T here. No change. Q of T. The present time I'm working with. No change. Is that okay? This Q here is talking about my Q plus 1, the next state. Is that okay? This ending here, you could have changed it as QT plus 1. The next state, when I receive this signal. Is that okay? And the next state here, instead of me to have any signal, it will just give me whatever is the previous state is. No change. It will just give me the old state. No change. Meaning my Q of T will be equal to my Q of T plus 1. Are you following? Why this one will give me the old state as it is, and this one is an invalid state. And when you come to this Q prime, you will also have similar results. Okay? Whereby this one will become an invalid state, and this one will become a no change, which will give you Q of T. Okay?
Yes, sir.
Now let's go to the one we're looking at now. Looking at this, what do we have here? We now have Q of T plus 1, which is the next state we are expecting, haven't feed in this signal. So then this one return my Q of T, meaning no change.
No change.
Is that okay? No change.
Yes, sir.
Then going to the next one, this one maintains 0 and 1. It's still not different from what we have in SR.
SR.
Is that okay? Then,
yes, sir.
Instead of us to have an invalid in this place, the improvement on JK, we just make this one to give me what? Q prime. And my Q prime is just that what? It will just invert whatever I have as my previous state. If my previous state was 1, meaning this one will not give me what? 0.
0.
My previous state was 0, meaning this one will not give me what? 1. It will no longer give me an invalid state. That is just one of the major improvements you have in your what? In your SR. Sorry, your JK flip-flop. Okay? So it has that advantage over SR. Another very important advantage it has is the toggle function. I don't know if you understand that. The toggle function. What do I mean by the toggle function? If you look at it, by implication, what you have in this place and in this place is nothing but what? A toggle. Are you getting me now? This is a toggle.
Okay.
If my previous state here is 1, this one will give me 0. If my previous state here is 0, this one will give me 1. Meaning these two states can be used for what? A toggle function, the circuit. Okay? Thereby, maybe you want something to on or you want it to off, and then you want a circuit that will operate in such a way. So this one can actually serve as toggle. Yes. It's like what?
Like a switch, sir.
Like a switch, exactly. So that is that. Let's go on. Then the next one is the T flip-flop. This one is called the toggle flip-flop. Toggle flip-flop, as the name is, toggle. Okay? It has a single input with the clock signal coming in. Okay? Toggle, as the name is. If T goes in, if T is equal to 1, the output will toggle and become a 0. Is that okay? And then if T that goes in is 0, the output will become 1. These ones are usually have the applications in a counter circuit. Then let's look at the timing diagram very quickly. The timing diagram. Now, when we talk about the timing diagram, you can see one on the screen. What is simply talking about is showing you what relationship exists between signals over a period of time. Okay? What relationship exists between the signal and the time. Okay? Time will always be on your y-axis. Time will always be on your x-axis, while your signal will be on the y-axis. Okay? So this is what it looks like. Okay? Some of the basic parameters we look for is the setup time. You look at the hold time. You also look at the clock to Q delay time, TCQ. Then we can look at the maximum clock frequency. These are some of the things that we can look out for when we talk about the timing diagram. The basic thing it does for us is that it helps us to be able to have a clear understanding of what the output signal of any of these flip-flop will look like. Okay? So that is basically the idea of what the timing diagram gives us. Okay. Any question? So far, so good. Okay, in the absence of none, I continue. Look at what I have here on the screen. We look at a diagram whereby diagram doesn't come out well here on the screen anyway, where we have an input that must be stable before the clock edge. Remember, I told you what TSU and TH is in the previous slide. Your TSU is talking about the setup time, and then this one is talking about your holding time. Okay, so if you look at what we have here, towards this side, you have your TSU. Okay, the signal is coming here, and at this point in time, it goes up here. Okay, your TSU, the setup time. Okay, the setup time is running between the beginning of this signal coming, when it has not come up to the point where the signal goes up. Okay, and when it goes up, the setup time stop and then you have your holding time. So the holding time, we also get to a point, and the next thing is what? It will drop again, and that can continue on and on within that circuit. Okay. And we also have the time between the clock edge and the output. Okay. So you can also look at how all these affect the critical timing for your analysis. It can also be extended to how the operating frequency is also affected by all these parameters.
I know they understand.
Hello? Hello? If you are speaking, speak out. Okay? Hello?
Sir, we don't understand. We don't understand. Some of us don't understand.
Said, who is that Zoom user talking? You are just coming into the class now and say you don't understand. I don't want to hear your voice. I'm the one admitting you to class.
I've been trying to join, but there's no network.
You are the one just coming in now. We don't understand. Please, don't talk like that in my class. Is that okay? If you want to ask any question, you ask responsibly. And provided you have been following since I started, not that you just jump in anytime you like and think, I can choose not to admit those of you are coming late. Okay? My whole Zoom class, you are coming in about an hour into the class and you're telling me we don't understand. So anybody that want to ask any question, go specific. I can see everybody in class. So specific questions, and I will go over. Anybody having any question? Anybody having any question?
No, sir.
So those that are not listening in class are the ones that will complain. We don't understand. You generalize. Okay? Then we talk about the edge triggered. Edge triggered. Now, if you look at this arrow, it's pointing to this edge. It's pointing to this other one, is also pointing to this edge. Now, this signal is coming this way. At this edge, there is a trigger that pushes this signal up. Okay? So when we say edge trigger, we're talking about a change of states at the clock edge. Remember, we're looking at the axis of time. Okay? At this edge, there is a change, and the signal goes up here. Okay? Now, when it gets to this edge too, there is also a change. But this time around, the change is that what? The signal comes down and it continues. And you can see the arrow indicating the trigger we have in these two places. This trigger at this edge push the signal up, while this other one push the what? The signal down to this side. Okay? We also have what we can refer to as level trigger. Level trigger. When we talk about level trigger, this one causes a changes why clock at a particular level. Okay? And definitely this one's simpler, but they can be more prone to error because there is no indicator to tell you that the signal is changing. Look at it. You can see this arrow just going, just going, just going. It's going at a specific level. You don't really have any clear understanding of what is happening. Okay? You just see the signal just going there. So it's prone to error because it can be difficult to really identify where the signal is coming from or which direction is going. Okay? When we want to design sequential circuits, use any of these flip-flop, there are a number of things to put into consideration, which will definitely influence the choice of which one you're going for. Okay? And these are some of the factors which I believe you can actually look into and then consider them and then read more about them. Number one is the clock skew and jitter. And then the next one is a metastability issue. Then you have the power consumption. Then you have the fan out limitation. And lastly, you have the noise immunity. Now, by noise, what do we mean? when we talk about digital signal, by noise, I'm not talking about you shouting or raising your voice in your classes. No. When we talk about noise, we're talking about unwanted signal within a circuit. Okay? So that is a noise. For instance, you are expecting a signal to be fully sinusoidal, but you are seeing some waves there. Okay? So we can say that signal is clean. So such a signal can be considered as noisy. Okay? So you need to consider noise immunity when you are trying to design your sequential circuits. Okay? An area of applications. Remember I mentioned earlier talking about your laptop, for instance. If you hibernate, okay, you can hibernate and still come back and you still have all your work intact, okay? You can recover. So these are the common area where flip-flops are being used. You have the register, you have the data storage, okay? You have registers, you have them in your computer system, okay? You have counters and you have frequency divider, okay? You have state machines, you have memory elements in your processors, and then you also have synchronization circuits. These are all areas where sequential logic can be applied, and then it can be very useful for various applications. So I have some questions for you, which you will definitely see when you pick up this material from the lab exchange. I will drop them hopefully before the end of today. Any question on this before we'll go to the next module very quickly? Questions, comments? Questions, comments? No question, okay? I believe you are prepared for my own question anyway. Who is that person? Elsa. Elsa, can you mute yourself? Okay. So, in the absence of any questions, so I want to stop sharing this and I will quickly share the module 6 with you. I will run through that one also very quickly. Can you see that?
Yes,
hello?
Sir. Yes, sir.
Okay, so in this one, we'll be looking at counters and registers. If you have noise in your background, common courtesy should tell you to mute yourself. Okay, let's learn public engagement. It's for our own interests. Okay, learn how to engage the public politely. It's okay. So under this one, we'll be looking at the part 2. We're looking at part 2 of the lecture on sequential circuits, okay? And this one talks about counters and registers. Counters and registers. What are counters? Can anybody make an attempt and tell me what you understand by counters? What are counters? Anybody? Anybody? Okay, let me engage you a little bit and call you. even though those who are in class and those who are not in class.
Okay, sir.
Money, it's like you are the only one in class. Don't worry, I won't call
I'm
you.
here, sir.
My
Don't
class,
worry.
I'm
Don't worry, I'm not
We are
calling you.
here. We are here.
Ojo
My
We are
Blessing.
here, sir.
class.
How far we
We are
there?
here, sir.
Ojo
We are here, sir.
Blessing.
Everybody
It's
there.
okay. Ojo Blessing. What do you understand by counters in sequential circuits? Ojo Blessing. She's not here, or he's not here. Ojo Blessing. Okay, so not here.
Hello, sir.
Is that Ojo Blessing?
Yes.
Okay, so what do you understand by counters?
They are used to count pulses or events. Electronics used to count pulses or events.
To count. That's
Pulses or
okay. Yeah.
events.
Don't worry, you're having feedback. It's okay. Who is this Emanuela Odiase? Emanuela Odiase. What do you understand by a counter in sequential circuit or in logic circuits? Emanuela, are you there? Emanuela. Is she there? Okay, who is this Zoom user? Zoom user. Tell us your name. Zoom user. That's the name you have there. Zoom user. We're the one talking earlier. Zoom user. I've asked you to unmute. Zoom user. What's your name?
Oh.
That's the name you used to join. Part of public engagements. Your name is not here. So how do we capture you for attendance? We'll put Zoom user there. And your HOD will look for your name as Zoom user in your departmental record. Okay, the next person, Zoom. Who is Zoom? Another person is Zoom. You can see those ones are not in class. That's the implication. They will connect the device and walk away. Zoom. Not in class either. Okay. So many of you just connected your device and walk away. Ayomide Michael.
Sir.
Okay, so can you define counter? No idea. Presley. Presley there. It's okay. So you can see majority of you are not in class. Those of you that have called your name, I've noted it. Oh, those of you that I call your name and then no response from you, it shows you only connected your device and walk away. You are purely on your own. So when the time comes, we'll reconcile all of that. So let me quickly go on. Now, we'll look at counters, type of counters, register fundamentals, type of registers, and then we'll look at the applications and the basic design examples very quickly. That's what we'll run through. What is a counter? Let's start with that. When we talk about counter, we're talking about digital circuits. And what does it do? It stores and counts binary numbers. It stores and count binary numbers. Okay? And they are very useful in so many situations. Like, for instance, when you talk about clock pulses, for instance, in the JK flip-flop, you will see CLK, clock, clock, clock. Is that okay? When we talk about clock, is that okay? What clock usually does is that maybe you have a counter that will just be sending 10 10 10 10 or 01010 as the case may be. Are you getting me now? So you have a counter that does that, or maybe it will count 111 000 as the case may be. So that is what basically you have there. So we can have binary counters that will count 0 0 0 and then 1 1 1 1 1 and so on and so forth. We can also have decimal counter, okay, that will be able to count from 0 to 9. But remember, even though you are saying it's counting from it's a decimal counter and counting 0 to 9, remember the basic building block behind it is that what? It is counting what? It is counting from where? Counting using binary basis too to do the counting. Another type of counter we also have is the one that is called the Johnson counter, and then we have a ring counter. Johnson counter in its own case is a type of ring counter, and what it does is that it produces a repeated sequence of outputs. Like I said, 0 1 0 1 0 1 0 1 0 1 0 1, or maybe 0 0 1 1 1 0 0 1 1 1 0 0 1 1 1 0 0, or things like that. Then we have a ring counter. This type of counter is a counter with a fixed number of states in a circular pattern. So it has fixed number of states in what? In a circular pattern. Okay? Some of your people are still coming to join just now, that the class is almost over. Now they want to join. Okay? We talk about flip-flop, and then wait. Oh, okay. We've talked about flip-flop. We have talked about clock signal, and then we've talked about the array of applications. So let me leave this page. Now, type of counters. We can also talk about type of counter. Remember, I mentioned type of counters generally now, that we can have binary, we can have decade counter, we can have a Johnson counter, we can have ring counter. Okay? That is talking about based on the classification as a function of their sequence of counting. Am I communicating, everybody? Am I communicating?
Yes, sir. Yes, sir.
Yes.
Yes,
Let me
sir.
go
Yes,
over.
sir.
Yes, sir.
I've
Yes,
just given you
Yes, sir.
four classifications
Yes,
of
sir. Yes, sir. Yes, sir.
counters. Thank you.
No, sir. No, sir.
Who is the noser? Josie iPhone. Is it Josie iPhone that is saying no, sir?
Yes, sir.
Eh? Josie iPhone that just come to class now. You are saying no, sir. Who is saying no, sir? Let me see the no, sir. It's okay.
I'm not going to class now. I beg you.
Josie. Who is that Josie iPhone talking? Can you unmute yourself and speak to me now? Otherwise, I will remove you from this class immediately. Who is that Josie iPhone? Josie iPhone.
Sir.
What did you just say now?
I said I did not come to class now.
You don't come to class. I was the one that just admitted you now.
Okay.
You just admitted. When did you join the class?
So,
when?
The time.
When did you join the class? Answer me now.
Around 5:50 something.
And you didn't just join now. You can see why are you like this?
No, he said now. I don't join now.
Listen to me. A class started 5 p.m. and you join 5:50 something. You say you didn't just join now. And you have the God to be telling me we don't understand. Please behave yourself and behave yourself responsibly. Is that okay?
Yes, sir.
I'm the one that admits each and every one of you to this class. So when I tell you that you are just joining, you are just joining. You joined barely many minutes ago. And you tell me you are not just joining. So if you have any question to ask, you will ask responsibly. Please, I don't understand.
Sir.
Not that we don't. You don't use the word we. I don't understand.
Sir.
And if I consider it necessary, you'll be here long enough. I will take my time to explain again. So don't be creating wrong impression in the midst of the crowd.
Sorry,
Always
sir.
present yourself responsibly. Is that okay?
Yes, sir.
Good.
Sorry, sir.
That's okay. Now, I was trying to lay a foundation that I just explained to you 4 classifications, okay, based on the accounting sequence. And I talked about binary counter, we just count binary number. I talked about decimal counter, which counts from 0 to 9, counts decimal numbers. And then I talked about Johnson counter. It's a type of ring counter, but it produces repeated sequence. And I said it could be something like 00111, 00111, 00111. That would be the sequence of what is counting and is giving as the output. Then we have the ring counter, which on its own, what does it do basically? It's just that it gives you fixed number of states in a circular pattern. Okay? That is what you can have in those situations. However, we have types of counter based on their mode of operation, not based on what they are counting now. And under that category, that's the one you have on the screen now, which is the one that we have as what? The asynchronous and the synchronous. Okay? The asynchronous counter and the what? And the synchronous counter. Those are the 2 types. Okay? Now, in the case of asynchronous or asynchronous, as the case may be, this one is also referred to as a ripple counter. Okay? What happens is that the clock drives only first flip-flop. Okay? The clock only what? Drives the first flip-flop. The output of each flip-flops triggers the next flip-flop. Okay? The output of each flip-flops is the one that will trigger the next flip-flop. Okay? Then the next situation is at that point in time, the system begins to work. Now, we said it's asynchronous. Why? Because the signal clock goes only to the first flip-flop in that circuit arrangement. Remember, when you are designing a counter, you may have as many flip-flops as possible that will go into your circuit diagram. Okay? You may have as many as possible that will go into your circuit diagram. Okay? So remember, in asynchronous, it's only the first flip-flop that gets access to the what? To the clock signal that will trigger it. And once it triggers through the clock, then is the output of the other one that will trigger the other flip-flop in the system. So why is it asynchronous? It's asynchronous because all the flip-flops are not triggered at the same time. Okay? All the flip-flops are not what? They are not triggered, they are not activated at the same time. Okay? So the first one needs to work and produce output to be able to activate the next, and then on and on within the circuit. Okay? The question is, why going for asynchronous? It's simple to design and it's very easy to design. Okay? And then the propagation delay issue is also another disadvantage you will find in such a system. Propagation delay issues. Okay? Because definitely you should expect the system to be slow. Because definitely one flip-flop needs to work before the other one will work. compared to the case of a synchronous one where you have clock that drive all the flip-flop at once. Okay? All the flip-flops, they're activated at once through the same clock signal. Okay? And so their state changes automatically within the circuit simultaneously. Okay? However, this one also comes with its own disadvantage. It has more complex design, but definitely it will come with an advantage that what? It will offer better performance. It will offer better performance. It will offer better performance and then give you a more reliable counters compared to what you can achieve with asynchronous type. Okay? This Emmanuel, you are playing with this device too much. I will remove you from the class. Okay? Pay attention and listen and stop playing around all the tools you have in your Zoom meeting. Okay? Now, this is what you have in asynchronous. Okay? Look at it. The clock power the first one, and then the second one need to activate the first one need to activate this particular second one, and this one on and on and on. So in this type of situation, you should expect that definitely this time will be slow. Okay? This is the output of the first one, output of the second one, output of the third one, the fourth one here. And what you have, the second output is the one acting as signal that will activate the other flip-flop. That is asynchronous. Okay? Then this is what you have in a synchronous one. The signal that is coming pass through each and every one of them. Okay? And the signal reach out to them all at once. Mike, Igozuruike, Mike. Okay? Let's go on. What are the characteristics of counters? What are the characteristics of counters? Number one, it has modulus characteristics. That is, the counting sequence length is one of the key characteristics that you will need to take note of when you're talking about counters. Number two, the direction can either be up or down. Number three, the timing can be asynchronous or synchronous. And then the counting sequence, of course, it can count in binary. It can also count in binary coded decimal, BCD. BCD. It can also operate in a gray code. Gray code. I think I've taught you about gray code. I don't know if I mentioned binary coded decimal. But even if I've not, you can go and check out that and take note of what it is. Then we talk about the ring counter and Johnson counter, which I just mentioned briefly just now, under the type of counting sequence. Okay, so we have the binary coded decimal, we have the gray code, we have the ring counter, lastly we have the Johnson counter. Okay, this is what your ring counter looks like. Okay, you have the single one. Jane, you are still drawing. Okay, you have the single one that circulates and flip-flop for end states and is simple to design. Okay, you have just a single signal that goes through the number of flip-flop for the number of states. And it's very simple to design because the ring will just keep going round. Okay, the Johnson is a modified version of what you have for what you have for ring counter. Okay, you have two end states with end flip-flop, and then you have an inverted feedback. Okay, you have an inverted feedback. Okay, those of them that are writing on the screen, I believe they didn't have opportunity of playing with toys when they were much younger. So they consider Zoom as a toy to play with now. So maybe I will plead with them. Please suspend playing with Zoom. It's not a toy. It's a platform for us to engage academically. Okay? Stop playing around with everything you're doing there. Destiny. You are still writing on the screen. Okay? Now, let's look at register. Register this time around. Let's look at register. So when we talk about register, for instance, we're talking about a collection of flip-flops that are used to store multi-bit data. Multi-bit data. When we talk about register, we're talking about a collection of what? Flip-flops. And they are used to do what? To store multi-bit data. Okay? Now, registers are used in microprocessors, memory devices, and digital system for temporary data storage, for data manipulation, and then a data transfer. Okay? And we have several examples of them. Let's quickly look at their basic operation. What they do basically, they can load or write data, they can store, they can clear, they can read. That's register. Okay? And then the control, you have the clock control, you have the enable, you have clear and reset, you have load. These are the type of signals that you can have within the register. Okay? Now, the basic register types, the basic type. We have the one we call PIPO, SISO, SIPO, and PISO types, the basic type of register. The PIPO, you have parallel in and parallel out. SISO is serial in, serial out. Then you have the SIPO, serial in and parallel out. And here also you have the parallel in and serial out. These are the basic arrangement you can have for a register. Remember, we said register is what? A collection of what? Flip-flops. Okay? Collection of flip-flops. Is that okay? And so if they are collection of flip-flops, we are saying you can have them parallel in, parallel out, meaning you parallel all the inputs and you parallel all the outputs. Okay? You can also have a situation whereby you will series all the inputs and also series all the outputs. Okay? And then the next one is that you can also series inputs and then output all the parallels, put output in parallel. And then lastly, you can also have all the parallel, all the inputs in parallel, and then you have all the outputs to come out in series, depending on the one that fits into your application. Then they have special type of register. First one is universal shift register. The second one is bidirectional. The third one is buffer register. And then the last one is what? Address register. All these registers, they all have their specific and peculiar applications in their various area, okay? In their various applications. Remember we said they are used in microprocessors. And when you talk about microprocessor, you are talking about what? A mini computer, okay? When you talk about microprocessor, you are talking about what? A mini computer, okay? Now, let me say this before I continue. I said I'm going to give you a classwork to do. I see that some are connected here, some are going out, and the population I have here has been around 50. Once I start to give the test, whenever I decide to give the test or the classwork or whatever name you want to call it, nobody will be admitted again into this class. Is that okay? Those of them who are just feeling this is the best time not to join or to join, they will be on their own that time because I won't even be available to attend to anybody. If a class has been on since 5 p.m., this is 6:32, and some are still just joining now. These are the ones that will come to class and tell you stories, okay? But there's no problem. So this is a 4-bit PIPO. 4-bit PIPO register. Okay. What did you see here? That is parallel in, parallel out. Parallel in, parallel out. Look at it. The clock. This clock arrangement. What type of arrangement is this clock now? What type of arrangement is this clock now? What type of arrangement is this clock? Can somebody tell me? We talked about it.
Serial in, serial out.
No, I'm talking of the. It's not serial in, serial out. You even see it on the screen. This is PIPO register arrangements. Is that okay? I'm talking of the clock. Remember, this clock now is activating all the flip-flop at once.
That's parallel in, parallel out.
No, it's parallel in, parallel out. I'm not even talking about the signal now. Are you getting me now? I'm talking about the clock now.
Okay.
Is that okay? So this clock, okay, let me go back so that you will see where I mentioned that briefly.
Synchronous.
Did you see?
Synchronous.
What type of arrangement is this?
Synchronous counter.
Don't speak in tongue, go. Synchronous. So you can say the clock, all these flip-flops, is connected to all the 4 flip-flops at once. Unlike asynchronous, whereby only the signal comes to this one and the rest are not taken from the output of these arrangements. Okay? So let's look at this one now. So meaning this what? This arrangement here, the clock signal coming to this place is what? Is synchronous, getting to all the 4 flip-flops at once. Okay? Are we together?
Yes, sir.
Okay. We now talk about parallel in and parallel out. Okay? It's a 4-bit. So for this one, we have the first one, the second one, the third one, and the fourth one. All the inputs are coming here as a parallel signal, and they are all the outputs here are also coming out what? As a parallel output. Okay? Let's look at the next one. Look at SISO. Okay? This is the serial in, and this is what? The serial out. Okay? The clock comes into this place, and the input comes in here. The input of this one goes to this place, goes into this place, goes into this place, and come out here. I don't know if that makes sense.
Yes, sir.
Then,
Can you go over it again?
Okay. Look at this one. You can see the clock gets to each and every one of them at once. And then you have the input coming here for each of the flip-flop and the output coming out here for each of the flip-flop. Okay?
Yes, sir.
And looking at the next one, excuse me, you only have the input coming here and the output coming here, meaning the output of one goes into the input of the other, and it goes on and on and on until you have the final output.
Okay,
is that okay? So serial in,
Yes, sir.
serial out. Then we have the universal shift register. This particular one is the most versatile type of register, one. And the operations involve the parallel loading shifts, left, shift right, hold current value. These are the operations and the control inputs. It has a mode to select 2 bits typically. And then you have the clock and the clear operations that the input can take at any point in time. What are the applications of counters? What are the applications of counters? Yeah. Counters have so many areas of applications, Let's look at, for instance, we can talk about the digital clock system. It can be used for time and then a date display. It can be used for alarm functions. Memory system. It can also be, When I was studying back then in what year was that? Hello, who is that person? Hi. Not ready to listen, also willing to distract others from listening. It's not good enough. Now, gone are those days. There is a small IC called 555 timer. Okay? This 555 timer, we used to use it to actually design so many of these clock circuits. And then you will see how some of these things work. Maybe I will see if I can get some of the simulation environment for that. And then I can use it, or maybe send a link to you for you to go and look at it, because I may not have the time to take you through all of these things in the class. Okay? Now, so a timer is a type of IC and actually be very useful. So where am I going? We use all those that using using a 5 timer and using this concept of counter register to actually design a mini keyboard whereby you can play do, re, mi, fa, sol, la, ti, do, things like that. Just making use of just resistors and then all those basic stuff. So these are some of the things you can actually do. You can build by yourself, playing with 555 time and related stuff. Okay, so alarm time, alarm function, memory system, address counter, data buffer, digital communication, serial to parallel conversion, data synchronization. Now, we have serial to parallel conversion. Counters and register can actually be used there. When we talk about serial parallel conversion, you are designing a circuit, you have bought maybe a sensor, and that sensor comes with those who are connecting and disconnecting. I won't admit you again if it's becoming too much. Okay. You can actually design your own serial to parallel converter. Okay, whereby you have a sensor that can probably maybe accept serial, and then the output or the signal input you have in your microcontroller you are using is just parallel. Okay, you can design a serial to parallel converter, parallel to serial converter using clocks and using counters and registers. Okay, microprocessor system, you can use it to program counters and give instructions to register. These are some of the basic things that you can actually do with counters and register. Okay, a typical design example is what you have here. You have your states. You have Q0, Q1, Q2, and Q3, and then you have the time within different states that you can actually play around with and see what it will look like. And then you have practice question, which I will also want you to look at when you receive the material from me. So in the absence of any other question, if you have question, you can ask me now. And if you don't have any question, I would like to give you my own question right now. And please listen to the instruction very well. Listen to the instruction very well. Okay? Are we ready now? Just give me a thumb up if you are ready to take instruction. Just give me a thumb up. You don't need to talk. Everybody will be talking. Okay. Good. Now, please listen very carefully to the instruction I want to give you. Okay? It's just a classwork. It will run for like 5 minutes or 10 minutes. Hello.
Sir, please continue, sir.
Are you paying attention to me?
Yes, sir.
So, listen to the instruction I want to give. I want to give you just a very simple question. Just a very simple question. And the simple question I want to give you will require you to just, and please listen. I'm giving you the question on lab exchange. So those who have deliberately refused to join the lab exchange, you are also shortchanging yourself this evening. You understand it now? Those of you that have refused to join, you are simply shortchanging yourself this evening because even though you attended the class, you won't be able to participate in this simple question I want to give you. Okay? So, but if God will help you, you may quickly go ahead and then maybe do the needful. Then maybe I'll be willing to accept you. I don't know. So I'm giving you a simple question on the lab exchange. And then you will answer the question and then they give me the answer also in the lab exchange. Now, see what you are doing, please. See what you are doing, please. Answer the question on a piece of paper. And then, let me see, can you upload the lab exchange? Let me check if you can upload your image, and if you cannot upload, you need to type, okay? If you can't upload, you may need to type. Just a minute. Just a minute.
Sir, please, I have a question.
You have a question?
Yes.
What's the question? Go ahead with your question.
This lab exchange, you say we should do this assignment, this classwork.
Yes,
I don't know. Is it here or is
it what?
I don't understand where to get it from or something.
Somebody should help me explain to him. Oh.
Well, I mean, explain, give me a big.
Don't speak pidgin language in my class. You hear me?
Sorry, sir. Please explain to me.
Okay. Somebody should help us explain to him. Oh.
So the lab
He's the son of President Tinubu. Please help us explain to him.
So the lab exchange platform is just like a platform where you can have classes and modules uploaded. So you just have to register on the lab exchange and it will approve you. That's all. They'll be able to see the.
Has the information ever been posted on the?
Yeah, the links are also have been posted on all platforms under.
It has been posted.
Yes.
And then you should ask him question before you answer his question now. Ask him question. Why is he just asking now? Is it that he's just resuming for the semester? Or where has it been? When the information has been flying all these years, all these months. Let him answer you some question before you also answer him. Let him answer you. Can you answer the question? Where have you been all along? Where have you been?
So I've not been around.
Okay.
I've been quite sick.
You've been what?
I've been sick. I've not been feeling too well, sir.
It's well, oh.
Amen,
but
sir.
you are fine now.
Yes, sir. We thank God, sir.
It's well.
Thank you very much, sir.
When it comes to sickness, we can all be emotional about it because we don't wish anybody sick.
Yes, sir.
So let's leave it at that.
All right,
so,
sir.
Now, can you what?
Register on the lab exchange now.
You can still register. You can register.
Right.
You know what you will do? You know what you will do?
Yes,
I will project the question on the screen now.
Okay, sir.
So answer the question on a piece of paper.
Yes, sir.
Are you getting me?
Yes,
and be ready to snap and upload. Is that okay?
Yes, sir. Thank you, sir.
That you should do so that in the next 5 minutes or 7 minutes, I will stop you from answering any question?
Sir.
Answer it on a piece of paper.
Sir.
Yes. What question again?
Sir, please, how are we going to upload the answer?
You will snap it with a clear scanner or whatever now, and you upload.
Okay, sir.
Or is that another difficult one? So I will check.
Please, the link for the lab exchange, please.
The link. Please, that whoever is looking for the link for the lab exchange, go and look for it on the WhatsApp groups. Is that okay? Don't come and ask that question here again today. If you know you were sick and you were not in school, when you come back, you will have asked for information on things that can help you to properly integrate. Is that okay? In as much as we are emotional
I send the link again,
about what happened to you.
Please.
See, pay attention, everybody. Is that okay? Pay attention so that you don't miss up the important points. The first thing now is that what? I want you to look at what I will upload on the screen now. I will show you on the screen now. Are you following me? The question. Are we together? Hello? Can you hear me, everybody?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
And once the question shows on the screen now, the next thing you should do is to answer it on a piece of paper. And the question you want to answer on the piece of paper shouldn't take you more than 5 minutes to answer the question. Okay? After you have finished answering, scan it to your phone and have it there. Before you finish doing this, I will send the link where you will upload it to. Is that clear, everybody?
Yes, sir. Thank you, sir.
So take one instruction at a time. So the time starts now because I want to quickly upload, show you your screen now. The question is coming on your screen right away. So with that, you should start doing the question. You should start attempting the question. It's simple, something what you have we have discussed over and over again. So I don't think it's an open book. You can open any book to do whatever you want to do. Just make sure you make a logical presentation of whatever you feel you want to give me. And if you don't make a logical one, no problem too.
Excuse me, sir.
Yes.
I just requested for the LabX. They said the request is pending.
Let it be pending. Is that okay? So I will
Okay,
attend to it when I have the time. Is that okay?
Yes, sir.
Just a minute. So you should have access to that now. I guess you can see it. Can you see the question?
Class. Yes, sir.
Yes,
I can.
Okay, good. So you have just 7 minutes to do this.
Okay.
Just 7 minutes to do this on a piece of paper. Okay? Ensure you don't copy yourself. Ensure you don't copy yourself. You should be done by now.
Almost done, sir. Sir,
Yes.
please, this number 3, I don't know. Is this the complete question?
What do you say?
Number 3 is the complete question.
What about it?
For a synchronous 4-bit counter account from 0000 to 1001, decimal 0 to 9. I don't know. It does not really
Okay. Let me, yes, it's not showing the full question. Let me quickly show the updated one. Okay, it's cut that page. Thanks for drawing my attention to it.
You're welcome, sir.
I will show the updated part now.
So nobody never updated. Oh, Jesus Christ.
Jesus Christ. So you have answered the question before now. If you are a genius, you can complete the question and set it by yourself now.
Have they even changed it? You didn't even know the difference. Oh, wow. What's time? 7 o'clock. The one I tell you.
I'm also in the office.
Can
you imagine? Doesn't concern you.
It concerns us. Don't mind.
You are not concerned about my well-being.
Imagine.
You should know that it was
an achievement for you that you are not concerned. You don't care. That's a lady talking, and you will get married one day with that kind of attitude. You better be concerned about the well-being of other people, even if it doesn't affect you.
The exchange not the work.
I believe that shows what you are raising concern for, please.
Thank you, sir, for the full question.
God bless you.
You are welcome.
Okay. Please pay attention, everybody. Okay, some of you are offline already. Now, you won't be able to, we are not using a lab exchange again because I've checked. We couldn't, you won't be able to upload except you have to be typing. So in order to make your work easier, I'm just going to share a link on this Zoom chat now. It's a link to a form, and the form will serve dual purpose. The form, first of all, will capture your attendance for this class, and at the same time, it will also give you an opportunity to upload your answer to the question. Okay? So I'm sharing that right away. And I will leave the form on for the next 10 minutes for everybody to upload. So by 7:15 on the dot, the form will cease to accept any response from anybody. I believe that is taken. So you have the form already in the chat. So quickly copy it to your phone browser wherever, because I'm going to end this meeting in the next 5 minutes. So that let me go home and go and rest for the day. Since nobody seems to care about my well-being.
Sir, we care about your well-being.
Okay, thank you for caring. I know men are always more caring than ladies.
Sir, we care the most.
You care, okay. But one of you said she doesn't care now. Prosper, you're raising your hand. Can you speak out?
Sir, please, the link is not loading.
The link is not loading. What's the challenge you're having with the link? The link is loading. Check what you're doing. I've opened the link here. The link is working perfectly well. Check. And please take note, if you have written more than one page, you need to scan it to PDF because you can only upload just one document. Is that okay? And your file must not be larger than 1 MB. Is that okay?
I'm back and front, so I have to like snap the front.
And right, just scan it to PDF because you can only upload one file. Is that okay?
Oh, okay, sir.
And it must not be more than 1 MB. That's the restriction, because you can't just overflow my space. So I believe that that should have taken care of the concern with lab exchange. And those of you who are not on lab exchange, you need to go there, because any material I will share with you will still be on lab exchange. Either way you go about it. Okay?
Sure, this for me. Look now. No, I've seen it before. Which one is it? Black person. Wait, when you have seen I mean, how? This lab is very upsetting. Yes, I'm seeing. Wow. I'm resisting just in there, for small pictures, for special. Can you help me with this? Okay, I should ask her. Yes, sir. Alero. You check your money. You know I don't relax.
But you don't need to PDF.
Excuse me, sir. Sir, there's a one limit.
What's talking?
Sir, there's a 1 MB limit for the
That
upload.
is it. So I don't need large files. You can't give me 2-page document and it will be more than 1 MB. So go and look for a way of reducing your file. You can't just be overflowing. That thing should not be more than 50 MB. Is that okay? I mean 50 KB ordinarily. So if you have a bogus file size, you will face that restriction. So you need to go and reduce whatever you are doing and make it minimal. Okay? And I said,
Sir, please, where's the link, abeg? Where's the link?
the link is on the chat, oh, my friend. The link is on the chat. Pay attention.
No, you might use camera with the.
Wait, when you press out, you see your show. When you press insinuous press out,
The link is working. Oh, check what you are copying. Is that okay? The link is working, and I'm about to close the link in the next 6 minutes. I've pasted the link again. So those of you saying the link is not working, check whatever you copy and ensure you copy the right thing.
So now exceeded the limit.
You need to work around it now and reduce it. It's not my own headache.
Okay, sir.
How can you be scanning 1 page or 2 or 3 pages and it be more than
No,
1
no,
MB?
it's not. Okay. Yeah, no, let's try it.
Your answer should not be more than 1 or 2 pages at most. So if you want to scan with low resolution.
That is just 1 page.
How if it's just 1 page? How can it be more than 1 MB? So go and check whatever. It's better you go and use a scanning app like Clear Scanner or Cam Scanner.
Sir, please.
Like what? What's the challenge you're having?
I beg.
Let me see if I can send the link of Clear Scanner to you guys. So you scan it, that one will give you minimal size. Clear Scanner, you can search it in your this thing. You can search for it in your Play Store, whatever type of app you're using. Who is this person saying the link is not working? Some people are submitting, you are saying the link is not working. What's not working in the link? What challenge you are having? Jane, what challenge are you having with the link? Jane, is she in class? I have 7 of you have submitted. I'm seeing the files here. Okay. So, those of you having issues, you should check whatever you are doing and do it right. I have 7 persons who have submitted already. I'm monitoring it. So the link is working. Jane, the link is working. So check whatever is not working at your hand. And this is 7:15 that I promised I was going to stop it. Okay? So any moment from now.
I'm still having issues compressing the.
Oh yeah, quickly compress. I will give all of you the next 5 minutes again. So I want to end this Zoom meeting now. And maybe I will give you the next 10 minutes by 7:25. I'm going to stop this.
Sir, please resend the link for the.
I'm going to stop this form. And I believe by then, everybody who is ready to submit should have been able to submit. Okay? So, on that note, I want to say very good evening to each and every one of you. Thanks for your time. And thanks for your attention as well. I wish you all the best. Hopefully, maybe next week, if you have the opportunity, may be able to come around physically. And then a class trip, the assignment you have collected, please, maybe you will look for a way of passing it across to me. Let's talk about it, and let's look for a way of you passing it across to me. And in the absence of any other communication conversation, beautiful and good evening to you all. And I say God bless you. Enjoy the rest of your evening and keep reading, keep learning, keep improving on yourself. God bless you. Bye.
Sir, it's not working.